You must have seen this kind of a pattern on the EEG. Sometimes the alpha rhythm, the posterior dominant alpha rhythm, takes this kind of a spindle appearance. And you can, so I'm just zooming out and I'm zooming in. So you see this kind of a pattern sometimes in the posterior dominant alpha rhythm. You can also see this similar pattern in beta frequencies. When you're seeing, when a EEG has a lot of beta activity, sometimes you see a pattern that appears like these kind of spindles. So what really does this mean? This is what I will basically try to explain in this brief tutorial. So this is a combination of two frequencies. So let's say that this is one frequency. So you see a frequency. If you look on the left side, I'm using Desmo's graphing calculator, and this is a wonderful graphing calculator. This is available on the web. So we are using y is equal to sine 18x plus 4.6. So what basically I'm doing is I'm creating sine waves with a frequency of 18 hertz. So these are in blue color. Okay, then I draw some more sine waves, and these are in the red color. These are slightly different than the one in the blue color. So one is 18 hertz, one is 18.5 hertz approximately. So let's try to superimpose these two frequencies one on top of each other, and let's see what we find. So instead of 4.6, I'm going to change this to 2.6, and these two frequencies are superimposed. Now what do you see here? Something that is really interesting. The places, so I'm going to zoom in here. The red and blue, the peaks of these two frequencies are quite separated out at this position. So red is not superimposed on blue, and blue is not superimposed on red. So basically the peak of the red is in a totally different direction as the peak of the blue. And when these two frequencies are totally in different directions, you see a cancellation of these two frequencies, and that's the reason it goes down. The place where there is a maximum overlap, so let's see here at this point, the blue and the red lines are completely superimposed on each other. So when there is a complete superimposition of two frequencies, you see an increase, you see an addition. So this is a summation of the frequencies. This is a constructive interference of waveforms, and this is a destructive interference of waveforms. So basically, when two frequencies which are slightly different at one point they completely superimpose on each other, you get the peaks of these spindles, and when these two frequencies are in opposite direction and completely cancel each other, you get these sort of a trough of these spindles. So basically, when we are looking at an alpha rhythm of, let's say, 9 hertz, it's possible that some frequencies are 9 hertz, other might be 8.5, or some are 9, other are 9.5. And when those two frequencies combine, this is where you start seeing the spindles. And this is a very nice illustration of the constructive interference where the amplitudes are the highest, and destructive interference where the amplitudes are the lowest.